Hello?
Hello, Paul.
Yes.
Hey, my name is Ken. I'm giving you a call from the company Co-Construct. We were talking to you a couple of months ago about our software that might have been a good fit for your business. Does that sound familiar?
Yeah, it does, but we're not ready for it yet.
Okay.
Still quite a ways away.
All right, maybe 6 months?
Yeah, that's good. That's a
All
good.
right, Paul.
Okay, bye.
Thank you. Bye.
Hello.
Hey, Paul.
How are you?
Doing well. How are you?
Pretty good.
Good.
So, did you get my download of? Sent you tons of documents.
Yes, I did. Thank you.
You're going to be up all night.
Yes.
So I think one of the things that I've learned recently, talking to Megan, is that I've had this question by other students that I'm teaching as well. And when you're taking the practice exams for black spectacles, you can go to the review summary, and it gives you the step-by-step explanations.
Okay. Yeah. I mean, I noticed that sometimes it would give like a little brief description on some of the answers, but
yeah, I mean, that's true on some of them, but I was thinking mostly of the calculation ones.
Oh, the calculations. Yes. Yes.
Yeah, because what I did was you really had me scratching my head here on that one question, because you left out the first part of it.
Oh, did I? Oh, I apologize.
Yeah, it was said. Let me pull it up on the screen.
Okay.
You see that?
Not yet.
Okay, hang on. How about now?
Yes. Okay.
Okay. Yeah, so it's actually question number 2.
Uh-huh.
What was missing was that first sentence where I had the 7-foot value.
No, I had that included in
Oh, really?
Yes.
That's interesting because
Unforeseen site conditions dictate dimensional changes. Yeah.
really, because I didn't have it in mind for some reason. I
Huh.
only have mine starting knowing that the allowable bearing capacity. Anyway,
That's odd.
it's all water under the bridge. Anyway, so I was scrambling. I could, how in the world can you figure that out without knowing that?
That would be a little bit tougher. You're right.
So anyway, this thing is a screenshot which I sent you as well.
Right.
It's right.
Okay.
It's right from the review summary.
Okay.
So when you run into those calculation problems, you should be able to find it on the review summary.
Okay. Perfect.
It'll save you some time. I didn't check on this lumens one. You can go back into the black spectacles and see if they came up. I mean, it's actually really, really simple. As you can see here, there's got 2 choices. One candela is 12.56 lumens. So it's just since there's the output of 3 candelas by the luminaire would be 3 times 12.56.
That is pretty straightforward. So
super easy.
yeah.
And some of these things, people get really panicky. They think, "Oh my God, I forgot that formula or that equation," and
right.
It's as simple as that. And the one above it is a little bit more of a calculation type thing, but then you got to figure out the cosine 360 over 2.
Right.
So basically, it's easier just to know that 1 candela is 12.56 lumens.
Multiplied by 3, right?
And whatever they give you now, if they switch that up, right, and they say, well, you've got 37.7 lumens, how many candelas does that luminaire have? Then you just have to rework that formula.
Sure. Okay.
Right. Divide that by 12.56 and you'd get 3.
Okay.
That's the way I find a lot of those questions in the exam is you just need to know kind of one of the equations and then you can flip them around.
Sure. Okay.
And that's true with beams and girders. I sent you a link. My other class, I'm doing the beams and girders and columns.
Yes.
So that tributary, if you look at that first video, my goodness, that's so good. That guy does such an unbelievable job.
Video, yeah, and that was great. I mean, it really kind of pinpointed, yeah, exactly what tributary area is, how to calculate it, and
yeah, I mean, it goes all the way. If you follow carefully and you take some notes on each step, you can calculate the tributary area, the girder, the beam, and the column.
That's right.
I mean, he does all that in that one video.
Yes, that was very helpful.
But I gave you a whole thing, tons of stuff on the lumens and luminaires, which maybe if you got some coffee or something, sit down in Starbucks and read through it. But I only gave you a few things here. But then if you go to that file I sent you on lumens, it's really, really clear.
Okay.
I also found that phenomenally easy to read about luminaires and luminosity, intensity, etc. So I think you'd find that really helpful because sometimes you just need somebody to explain it in layman's language with some good graphics, and then it just kind of all makes sense. Okay, so going back up to your first question, all I did was simply just kind of explain it a little bit more than maybe what they had in the black spectacles. But of course, this is all in Chapter 10, IBC. Right. And what I did send you was an Excel cheat sheet. I kind of recommend my students to create their own Excel sheets. Right. Yeah, some of my students are just doing they're keeping notebooks. So one of my students is unbelievably copious. I mean, she listens to all the lectures. She prints out all the lecture notes in advance of the lecture. Right. So she's got them at hand, and then she takes copious notes. As I don't know if you're doing the lectures or not.
I am, yeah, and I've been taking notes throughout the lectures as well.
Yeah, so she kind of when Mike is actually drawing something on the board, he repeats that. She draws it up and then she writes her own notes and explaining. Right. Because if you just printed out the notes themselves, some of them wouldn't even make sense.
That's right. Yeah, and he does good. He does a good job with the graphics as well. Yeah, drawing things out and everything.
So I think her method actually is really, really good, but it does require copious note taking. Sure. But what I do with my Excel sheet, and I send it to my students because they said, what do you mean by that? And I say, well, it's basically when you're looking at IBC code or anything that you feel like you're going to have to memorize, and that would include like this the lumens equation. You'd have an equation sheet which just gives you some really quick things like 1 candela equals 12.56 lumens. Sure. And then reverse that and say 1 lumen equals 1 candela divided by 12.56 or something like so you just have that cheat sheet and you don't have to always go looking for it. Because what I found in the ARA, they give you equations that you find while testing formulas, but I don't like them very much. I mean, they're okay, but they don't really help a student understand exactly. Walk me through a couple examples. That's right. With that formula, and then I could understand it better. So I'm going to try and work with Black Spectacles to see if we can't kind of deliver some kind of a explanation of those formulas. Yes, because I find a lot of people they're just having a lot of trouble with that. Right. I mean, I would too. And how many where should the fixture be located with plumbing and the pressure is so forth. It's just easier if you've got a lot of examples than to follow the formula. Right. Anyway, so going back up to this thing, you'll see this in my cheat sheet kind of is at the vertical on the ramps. The level is a 1/4 inch. The changes in level 1/4 inch. High maximum shall be permitted to be vertical. Now again, as I point out, these are just memorization things. There's just no way you're going to learn this without memorizing it.
Right.
And that's why I say if you write down and do a cheat sheet instead of reading it on the IBC code, but you're actually writing it into Excel or you're writing it freehand, you'll remember it better.
Yes.
When you're actually doing the writing. Then the ramp rise of 6 inches requires handrails on both sides. That's obvious.
Yes.
Landing required area can be overlapped with the door, although there's a little bit of an exception there, is that the door cannot overlap a handicap space. So that has to be clear. And then it gets down even to more detail. When the doors open completely, it needs to be 7 inches clear. So it's just all those little things. I don't think that would be on the exam, but I would put that in the cheat sheet.
That's right.
Anyway. And then obviously the 30-inch rise for the landing, and you also know that you've got to have 5 feet in front and 5 feet at top of that 30-inch rise.
Right.
And then when you have a switchback, it would be 10 feet.
That's right. Yeah.
Right.
One for each ramp.
Correct. Because they'll have questions in there about you need a rise of 48 inches or something. Mm-hmm. So then you got to add 5 feet at the beginning, 30 feet, then 5 feet, then 18, then 5. Right, and that's what you get your total length of the ramp. Did you get that, or do you need me to repeat it?
Repeat it one more time.
Okay, so let's say that they ask the question. You have a rise of 48 inches.
Yep.
So the question is, how long will the ramp be? So I sketch it out. So basically, it's 5 feet to start.
Mm-hmm.
Then you got 30 feet.
30
to go 30 inches high. Then you hit another landing at 5 feet. So now you've got. Let me write that down. I'm not writing it down. So you've got 5 plus 30 plus 5. So you got 40 feet there, right?
Right.
So then you got to go another 18 feet to get to that, to get 48 inches, right? 48 minus 30 will be 18 inches, which would be another 18 feet. So now you're at 58 feet, plus another 5 foot for the top landing. So your total length of that would be 63 feet.
Okay. Yep.
Makes sense. So if you draw that out or sketch it out in section, it kind of helps you, or plan. It kind of helps you figure that out really fast. Okay, so we covered how to figure out that 8.5 thing. Unless you want to go through the formula, but it's basically just following the formula.
Okay.
If you have questions with it, we can do it again, but basically it's
P equals N over A.
Yeah, P equals N over A, and the N is the dead load and the live load combined.
Right. Okay.
So again, if you were to sketch that out, you'd have a column, and the live load coming down would be 160 feet is live load. Yep, 100 pounds is 100,000 pounds is dead load. So together, those are 260,000 pounds would be your N.
Yes. Okay.
And then the area is obviously 7 feet times L, because you don't know what L is.
Mm-hmm.
And so then you've got the P is the soil capacity, so that's 4.5 kips.
Okay.
So when you put that formula together, you end up with, if you know how to do your algebra, basically you've got to spin that around so that L basically will end up being 260 divided by 31.5, because you've basically 1,000 pounds is 1 kip.
That's right. Yep.
So you can get rid of the 3 digits at the end of that. That's all that they did in this formula.
Okay.
I mean, you could do it the other two. You could just keep adding. You could say 260,000 divided by 31,500. and you'd end up with the same thing. They just all they did was they just got rid of the 000.
That's right. Well, and I guess especially since the key is in kips over square feet, so.
Yeah, I noticed another question that somebody had. They threw at me, and the answer was in kips. I'm sorry, it was. No, that's a different question. Forget it. Don't confuse you. But well, I guess what my point was is that the answer was in kips. It wasn't in pounds.
Right. Okay.
So that threw them. They got it wrong because they put it in pounds and not kips.
And not kips. Okay.
So that's this really stupid thing for NCARB to do. I mean, it's still the same answer. But they say, pay attention to how the units that they want the answer in.
Just watch the units. Yep.
Okay, obviously they rounded that up to 8'3" instead of 8.25. Now, my understanding from NCARB is that they will accept a decimal. 8.25 feet should still be a correct answer.
Okay.
Unless they tell you something different in the question. Like I just said before, if they say answer it in kips or answer it in pounds,
right,
or round it up to the nearest tenth,
yes,
then you got to follow their instructions. But if they don't, they would accept an 8.25 or 8'3". For example, on the commas, for example, if the answer was 1,000 and you put 1,000, that would be okay. And 1,000 without the comma would still be correct.
Okay.
So I'm told that they don't take that away from you and ask for something, but if they say round up or round down, or round to the nearest tenth. So 8.25 would still be okay. If in 8.3 would be okay.
Okay.
In terms of decimals. Okay. The luminaire, again, we went through that quickly, but I mean, it's such a simple formula.
Sure.
Right?
Yep. That's very simple.
So I think if you just remember that, you'd be good to go. Yeah, this graphic that I'm showing, if you look down closely at that bottom left corner, you'll see it. The formula comes out to 12.56 lumens is 1 candela.
Okay.
That's where all that comes from.
That's good to know.
No, no kidding. Otherwise, you got to do a cosine.
Yeah, right.
Okay, on this one, the 2-story wood frame building, I think the trick here was that you got
this one, I think I got hung up on because I think originally I picked the cross bracing. But and then when I read the answers, like technically that's correct, but it's choosing the best answer. So
correct. That's right. I mean, what I always recommend you do is that when you're looking at the question, circle or highlight whatever you need to do to notice is highlight some key words. So when I looked at that question, the first thing I did was I circled wood framed. So I knew they're talking about a wood frame building, not a concrete building or steel building. And then I also circled the fact that it was regularly spaced punched openings for windows. Now that's a big keyword. I mean, basically that's the whole sentence, the whole question. But what that gave me a clue that an X brace wouldn't really work that well.
Okay.
Because you've got all these regularly spaced punched envelopes for windows.
Sure.
So that means that the X brace would probably stop before it got to the window studs. Right. The window studs would continue on up, and you'd have your jacks, window jacks, etc. So the X brace would still work, but ideally, if you've ever built a house or wood frame building, the plywood, the OSB board will go around the window frame.
Sure.
Or could go around it. So obviously that's structurally much stronger.
Right.
So that's why the X frame would be knocked out.
Sure. Okay.
The steel frame tube, again, I threw that out because it's a moment frame construction, which would be fine, but it's a wood frame building. So why would you have a steel frame tube in there? And obviously the gypsum on the interior, even though that does provide some lateral strength, it's not as good as OSB on the outside.
Okay.
So that's kind of my explanation.
Sure, and that makes sense. I guess, it's just a matter of honing in on what the question is
Yeah, and I
looking
think
for.
I think
And
you're right. I mean, you got to look at that. That question also said best, right? The best solution. So you have to
yes,
circle the word
best
best.
satisfies the lateral resistance.
Right.
Yes.
So of all those choices, even though some are plausible, the best one would be OSB.
Okay.
It's a little bit tricky the way they do that, uh,
Sure.
but they do recognize that that is making you think as an architect. Is what would be your
Yes.
choices?
Yes.
And some of them you can throw out right away, like the steel frame tube system. Again, the reason why you
Right.
throw that out is because you noted earlier that it's a wood frame building.
Yes. Okay.
Now the mortar joints. What I did was I basically gave you a whole description of all the different kinds of joints and how they describe them. And then I gave you a picture of them as well. So if you know what they kind of down below, there's a graphic.
Mm-hmm.
And if you kind of know what they look like, the mortar joints, and you can kind of see that which ones would work, which ones would collect water and freeze. So the choices again, some of these are plausible that they still would be okay, but you have to then look at the choices, and they're asking you to only select a number, 3 of them, right? I think.
Sure. Yep.
So I mean, in some cases, I point out if it's like the flush joint, the flush joint was an incorrect answer, but because the mortar is not compressed, it's less water resistant. So that means if it was compressed, it still could be slightly water resistant. So it's a little bit of a trick question. But
Right.
of those choices, since you can only pick 3, the rake joint, extruded, and the struck joint are the ones which are most susceptible. No, yeah, the freestyle. I mean, the
Yes.
flush joint, the V joint, and the concave are the ones that are best of that selection.
Okay. Yep.
Because here you see in the drawings, I'm showing the concave is good. The water would run out. The V joint, it would run out. The flush joint, it would not stick anywhere. But all the others,
Right.
it has a place of holding the water.
Yeah.
Actually, the weathered one is good, but they don't have that as a choice.
Okay.
You see that weathered
Yes. Yep.
joint. There's also one called, it's not even on here. It's called, I think I put it on my list here.
Was it the grapevine?
That tuck pointing. Yeah, the grapevine. You know what? I've never even seen a grapevine, but it's actually sounded pretty intriguing. It kind of looks like a colonial period with a little groove in the middle of it. I've never seen that before.
Okay.
So it's probably only in New England. And probably
Okay.
expensive homes. I can't imagine anybody paying a mason to do that.
Sure.
I'm sure it's a grapevine tool, but anyway, so this one, it particularly helps to know what these mortar joints look like to get that answer right.
Yep. Okay.
The electricity facts. I think obviously birds can sit on it because they're not touching the ground, right? And
That's right.
the same thing for a human. I asked that question. I Googled it and I said, well, what happens if a human's holding on to the lines? And you also wouldn't be electrocuted either. However,
because you're not the best path to the ground if you're
exactly. Well, you're not touching the ground either, so you're
Yeah.
not conducting electricity. However, they say that if a bird or a human, if you were holding onto the wire, and if you got close, the wind blew another line next to it near you, you could get shocked.
Okay.
So obviously there's something about the proximity to the wires as well.
Not that I'm going to go hanging on some power lines or anything,
right,
in the near future.
But apparently, if birds were on the line and a storm came and another line hit that line, and they were on there, they could get electrocuted.
Okay.
I just thought that was interesting, but that's really getting into the weeds.
Sure.
That's not the intent of this question. But basically, yeah, the electrical circuits always generate heat, and I kind of give you an explanation about Y. It's a flow of electrons. So that's generating it. The AC alternating current. This is a kind of a tricky question. It says that electrons flow from negatively charged bodies to positively charged bodies. That's correct, but it's also incorrect because I mean that would be correct for DC power. DC power only goes in one direction, but AC power is alternating, so it's going positive to negative, then negative back to positive.
Right.
So it's kind of.
I think that answer actually got me hung up a little bit when I was initially answering it, because they note that as one of the correct answers.
Correct. Exactly.
But you're right. It depends on what, I mean, it is true, but it also isn't true in some cases.
Exactly. It's true that they flow from negative to positive in both DC and AC, but because AC is alternating, it actually flows back as well.
Right.
Now, maybe they're just saying, look, based on the other choices you've got, right?
That's one of the better answers. Yeah.
That's the only answer that's plausible, because obviously electrons don't flow the speed of light. They travel at what is it? 1% of the speed 1%? Of light.
Okay.
Less than 1% the speed of light. And circuits do complete form. They do complete circles.
Yes.
So that's obviously the correct answer. And then generators create electricity. That's a little bit scary, because I think a lot of people think, well, that's why I use a generator, right? It's generating electricity for me, but actually it's down to the weeds of the generator's actually not creating electricity. It's the mechanical energy in the generator that's creating the force.
Right.
Of the electrons. So that's not really fair question. I mean,
well, and I think that's where I may have got hung up initially, is I think that I chose the other two correct answers, and then I chose the generator one over the electron flowing from negative to positive. But
no, I can understand it completely.
I guess I mean, it's just.
I mean, because I mean, that's why people buy generators, right?
Right.
Just to produce electricity for their house. But when you get into the weeds on it, the generator, it's, the argument could be, you know what, you're really arguing. Yes, that generator that I just bought will generate electricity for me, period. That's why I bought it. If you want to tell me that, explain to me the mechanism of the generator, then okay, but it's just a bad answer.
Well, and I mean, it would be the same thing as saying.
They should have checked the four that apply.
Sure.
Because the generator does produce electricity. It doesn't necessarily create it. Again, so they should have said the generator mechanism create electricity, or the generator. I don't know how they should have phrased it. It just is it's a bad answer.
So if I came across a question like that, let's say on the ARE test, I mean, should I just go with the more, with, something like the electron answer, because it's technically more correct, I guess, than.
Yeah, no, I think you got to go with what they're stating.
Sure.
I'm just arguing your point, is that it's not really a fair question or answer.
Right. That's kind of how I felt, where I was like, well, I mean, technically, yes, the generator itself, I mean, yeah, it's the mechanical.
I mean, if they want architects to get into mechanical engineering, then, you would know that answer. But, why would an architect need to know if a generator is creating electricity? Yeah, I've specified generators to my homes.
Right.
For the purpose of creating electricity.
Yes.
Right. So it's bad. In fact, I'll bring this up to Black Spectacles when they report to NCARB and say, come on, you want architects to be mechanical engineers to figure this stuff out, or really?
Right.
You could ask NCARB members, do you have generators at home? Oh, what do you have them at home for?
Right.
Oh, okay. No, you don't have a generator. You have a mechanism.
Yeah. You can't call it a generator. Yeah.
You can't call it a generator based on this question. No, to go
Right.
back to, if this comes up on the exam, just follow what we just went over.
Just go, yeah, go with the better option.
Yeah, the one that seems to make more sense, I guess. I mean, like I said, they should have. I don't know. They're getting to the weeds on that one, but that's how I explained it when I
Sure.
did the research on it. Is that generators do not actually create energy. It's a mechanism, the mechanical system that does mechanical energy supplied to it,
Right.
which means the fuel, right, the gasoline that you're putting into the generator is the energy which is then turning the mechanical material to create the movement of the electrons.
Yes.
That's the.
But I mean, you could make that argument about, I mean, multiple elements, of a building that.
Yeah, it's right. You could. Does it circuit breakers produce electricity, or where does the electricity come from? Does it come from photovoltaic cells,
Right.
or does it come from sunlight? Does it come from oil or coal-fired plant?
Right.
I mean, you could really go into the weeds on this. Anyway, I try and advise people not to overthink the question.
Sure.
And this is where you get into trouble when you start thinking, oh my God, what are they trying to, what do they want me to do here? Yeah, I mean, a generator. I've got a generator in my house.
Right.
It does produce electricity. So why wouldn't that be a correct answer? Yeah, that's just really bad. I'm glad you brought it to my attention, though, because I think I will mention it to Mark, the owner of
Okay.
Black Spectacles, and tell him to get to NCARB and say, you got to clean up some of this stuff.
Yeah.
This isn't one only example. There's several examples that we run into
Sure.
where I think it's they're asking too much of the architect candidate.
Yeah.
Okay, circuit breakers. This is also, I think, a really bad question.
Yeah, I got hung up on this
really
one.
Bad
and
question.
I was hoping we could talk through this one because it was just.
I mean, I understand they got flow limiting device. Okay, if it's analogous to the hydraulic system of flow limiting device, I mean, I've never even heard the word flow limiting device. It's either a valve, right?
Right.
But they don't give you valve as the correct answer.
That's right, and I think that's where I went initially too. I was like, oh, it'll be a valve, right? And because you're absolutely right. I wouldn't hear the term flow limiting device for a circuit breaker, especially that.
Yeah, so they give you faucet, flow limiting device, and pump and a valve. So as I went through and did the research on this and found the definitions, you can see that okay. All right, the purpose of a flow control, meaning a flow limiting device in a hydraulic system, is to regulate speed. Now, a circuit breaker doesn't regulate speed.
Right.
All the devices control the speed of an actuator by regulating the flow rate. Flow rate also determines rate of energy transfer. A circuit breaker is automatically operated electrical switch designed to protect an electrical circuit from damage caused by excess current from an overload. So in that respect, it's limiting the flow of current. Too much current.
Mm-hmm.
Not the speed of the current, but it's the amount of current.
Sure.
So that's how it could be considered similar. The water valve is basically allows you to turn water on and off.
Right.
And it's the same thing you do with a circuit breaker.
That's right, and I think that's where my head went to. Is
yeah, mine too. I'd say
I made that analogy
that's a plausible answer as well. Now, okay, so then you got to say, okay, I got it. The faucet, the faucet basically a faucet uses a valve when you turn it on and turn it off. So you kind of have to go through and say, okay, so now I'm not gonna let this question beat me. So of those four answers, I'm gonna have to go with flow limiting device as the closest thing to a circuit. I guess that's the only way you have to look at it, is that of those four choices.
Okay.
A flow limiting, just think of an electricity limiting device. Just change flow to electricity or current.
Sure.
a current limiting device, and that would help you answer that correctly.
Okay.
And the reason that I kind of look at that is because A, C, and D are just one word, right? And B is
Sure.
3 words. So I'm thinking,
Mhm.
okay, so what are they doing here? Did they put that in to trap me? Or are they trying to say that that's probably the one because it's the oddball?
Okay.
I throw faucet out, I throw pump out, and so I'd be
Yeah, it
stuck.
would just
I'd be
be
stuck
between
with B and
valve.
D.
Yep.
I'd be stuck with B and D. So then I would change the word flow to current. And once I did current limiting device, and I could say, okay, I could see that. Yeah, maybe that's analogous then. So that would work.
Okay.
Because essentially a circuit breaker pops, right? It
Yes.
automatically pops on its own when there's too much current flowing through it, as opposed to a valve, which basically turns on and off usually manually. I mean, you do have
Yeah.
valves which will shut off
I was
automatically.
going to say, but yeah, you wouldn't
But
normally have a valve shutting off.
yeah, exactly. I mean, if you got a problem in your basement, right, you go down and you turn the valve off,
Right.
or you turn your valve off for outside hose bibs in the
Yep.
wintertime or something like
Yep.
that. So that's all manual, whereas the circuit's automatic and the flow limiting device, I suppose you could say a current limiting device would make it sound more analogous.
Okay.
I mean, we've kind of beat that one to death, but I guess that's kind of how you have to think about it.
Sure.
And when you come across questions like this, again, I would probably put down the answer you think instinctually, you think is right, and then mark it and come back and review it.
Okay.
But don't waste a lot of time on it,
Sure.
because then you might end up overthinking. I know a lot of people, and I do this as well when I took tests, is that I'd put down my instinctual answer, and then I would go back and later on come back and I'd change it, and it was wrong. I was right to
Yes.
begin with.
Yeah, that's happened to me a couple times. I feel like where I went with my gut the first time, and then I went back and I probably overthought it, and I was like, yeah, I'm going to change to this, and
And I think if you get this again, I mean, again, I would just kind of switch the word current or current into flow if they're trying to make something analogous to water
okay.
and electricity, and see where that would fit. Because once you do that, then faucet or valve doesn't make that much sense.
And yeah, and I think us talking through it, that makes more sense now.
Okay, jump down to 8. What happened to it? Move down. Okay, joints used in the lamination of glue laminated beams. This unfortunately requires you to kind of know what those are.
Sure.
So that's kind of just a knowledge type thing.
Yep, memorization. Yep.
Memorization. So again, I would have a section in an Excel sheet, a cheat sheet on lumber, for example, and then I would have in different species, the moisture content required, those things which typically come up in exams that you would find on lumber. And I'd go to this Architect Student Companion book to get information on that, or the other good book is Building Construction Illustrated.
Okay.
Those books are good for getting you those kind of cheat sheet things really fast, because they're just they kind of hit the highlights. The other book I really like is the ARE5 review manual from Ballast.
Yep.
That's a really good book. So
Okay.
And sometimes if you're graphically oriented like myself, I'd sometimes like pictures. So that's why.
Yes, I think I'm that way as well. Where if I can see it and
Exactly.
visualize it, then it makes a lot more sense than just reading a bunch of text and being saying okay.
Right. Yeah, exactly. So when I look at that graphic, I know vertical finger joint, scarf joint. Got it. I know exactly what that is. And the same thing with his mortar joints, right? You've got to see
That's right.
a graphic helps you much faster.
Right.
And I think in those books that I mentioned as well, you'll see on lumber, which is the most efficient cut of a lumber piece, right? So they give you graphic diagrams of a quarter sawn, and so forth. So it gives you a better, clear visual as to what's the most efficient use of the wood.
Okay.
In terms of the cut. because I've seen that on the exam.
Right.
Okay, perforated drain pipes. I've done so many of these in my life. I know exactly the answer immediately, but basically what you're trying to avoid is running gray water, which is storm water, right, rainwater, into anything with sewage, black water,
Right.
because of the CSO problem. So raw sewage will flow over. So all the correct answers there, obviously avoid municipal sanitary and septic tank and water treatment. So obviously run it to daylight. I run a lot of mine to daylight if I'm on a slope.
Okay.
And municipal storm water sewer would be in a city where you can't run it to daylight. So you run into the sewer. And the reason they have a sump pump in there as a choice is obvious because if you're in a situation where this is also in urban settings, is that if you got a sump pump, then the storm drain can go in there and the sump pump will turn on and evacuate it.
Okay.
And you know where it evacuates it? It evacuates either to the storm sewer or to the sanitary sewer. That's where it goes.
It's out of sight, out of mind at that point. It's just
That's right. Well,
you know.
if they're giving me that choice, the sump pump, that's what I would have to put down. But it's not a great location for it.
Sure.
But because it is going to go back into more likely it's going to go to the sanitary sewer.
Okay.
But that's really what I think the intent is to are you aware that you need to move that stormwater away from sewer, black water.
Okay.
Any kind of black water treatment. They've got a huge problem in Detroit where I was working, where they've got the CSO problems, the combined sewer. So they're actually now taxing everybody in the city, colleges, churches, anybody with real estate. They're charging them a $75 tax for every square feet of impervious pavement, impervious surfaces, because they're getting the overflow runoff, sewer overflow.
Right.
So it's forcing everybody now to put in green roofs or pervious pavement.
Right.
Trees, so the trees collect stormwater. Anything they can do to minimize the amount of stormwater runoff.
Right.
So this could be kind of heading in that direction, and that's also part, and when you have floods, floods will overflow sewage treatment plants.
Sure.
Okay. Oh yeah, I forgot to answer number 10.
Oh.
I'll have to get back to you on that one.
Okay.
I don't know, I skipped that one. Yeah, I'll do that. I'll do that so you can actually see the different calculation methods.
Okay. Sure.
Oh, sorry about that.
That's all right.
I just looked at that and I said, wow. Okay, copper piping. I don't know what their intent is here. I guess just so you may know what the different types are, but I mean, come on. Really?
Yeah.
I mean, this is a plumber's job.
Right.
But basically, there's just 3 types: the type L, K, and M. And the as I show in this diagram, this image, the type L is a little bit thicker, and then a type M, so therefore it's going to cost more because there's more copper content. So a type M is typically used in plumbing, and then the type L would be used kind of as it's going outside to the water main.
Okay.
That's really the main difference between them.
Sure.
And the K copper is, they say that's used primarily for water distribution, fire protection, oil, HVAC systems, things like that, because it's the thickest wall. Okay. So you don't want to use it. I can imagine you don't want to use a lot of it because it would be expensive, but. And then the DMV pipes are in older homes. That's about the only thing you need to know about that. Okay. And they're typically all being replaced with PVC or ABC plastic pipe. So I think if you just knew those 4 and knew that the M copper pipe was primarily the one in plumbing, indoor plumbing.
Okay.
Maybe that's the difference. They may be asking you something about sizes. I don't know why they would do that, but as I point out, can you see my graphic?
Yes.
My sheet?
Yep.
Okay. So the outside diameter of a copper pipe is 1/8 inch larger than the nominal size. So, for example, a 1/2 inch copper pipe has an outside diameter of 5/8. So you got to add an 1/8 onto that 1/2 inch.
Okay.
And the 1/2 inch is the diameter of the inside. So the inside diameter of copper pipe is determined by the wall thickness of the pipe.
Sure.
So I don't know why they would ask you that, but just so you know that when they say a 1/2 inch pipe, what is its nominal size, or what is its outside diameter? You just know it's
add the extra 1/8 inch.
The nominal size of a 1/2 inch pipe is 1/2 inch.
Sure.
Whereas the nominal size of a 2x4 lumber, right, is 1.5 by 3.5.
Right.
And when you get up to 2x10, it's 9.25.
Yes.
Nominal. Okay, types of plastic piping used. I think I missed that question too. Boy, I must have been in a hurry. I'll get back to you on that one.
Okay, sure.
I mean, I kind of know what the answers are, but you didn't send me the answer, did you?
I did for that one. The plastic piping one was just saying.
Was this on a test, or just questions that came up?
No, this was on a different
exam
I was taking. Yeah.
Okay.
So basically, it was just saying which types of, it did talk about flexible versus rigid, and then which type of plastic piping is not used to supply water, and that would be ABS, is what the answer was. First, the other options were.
Yeah, a lot depends on other types. I wouldn't know how to help you unless you told me what the other choices were.
It was CPVC, HDPE, or PEX.
Just a minute, let me write them down. What were they again?
It was CPVC.
Okay.
HDPE.
Okay.
And PEX.
And ADX.
And PEX.
PEX. So they gave you 3.
And then ABS was the correct. It was the answer saying that was the type of plastic piping not used to supply water.
Not used to supply water. Yeah, it helps. It helps when you send me the whole question and what choices you've got. Yeah,
that I did. Those should be on the last questionnaire I sent you.
No, because I think I just copied and pasted it here.
Okay.
I mean, I can double check quickly and see, but I'm pretty sure that I just copied and pasted these in.
Well, I mean, the types of plastic piping was in my email, but then the attachment had the actual question itself, just talking about the
attachment.
Yes.
So you sent me 2 files.
Well, I sent you the email with the attachment.
I'm looking at our email trail. Well, what I'm reading from your email on Monday was from the attached questions. One of the main topics I'd like to review tomorrow's plumbing piping, including the following.
Yes.
So it's just those questions that I just copied and pasted.
There wasn't an attachment to it. Okay. Well, I'll resend that.
Yeah. Okay, that would help.
But I mean, what we've been talking about, that's covering, half the questions anyway, the hard and soft one and the flexible versus rigid. So
yeah, I mean, because all that I would do basically, I'd basically look at the possible choices and then go in and try and explain why CPVC wouldn't be right or HDPE wouldn't be right. But again, if it's a black spectacles exam, they should give you the explanation of what why those aren't
Well,
the
and
right answers.
this one was different than black spectacles.
Okay.
The questions on the piping were so.
All right. Yeah, it's annoying that sometimes you get answers and they don't explain.
Yeah, it was just
They don't explain it. Are you familiar with Gang Chen?
Yes, and I used some of his exams on the 4.0, so
because he does a pretty good job of explaining, I think.
He does, yeah.
Particularly the calculations one. Okay, the rigid pipes. I mean, what what I found interesting about these was that I guess I never really thought about it, was that the reason you'd use a flexible pipe in a trench is because it will give, whereas a rigid pipe won't. So a lot depends on that embedment that it's embedded in to help resist. So I think a good way to look at this is evaluating the pipe performance.
Okay.
Rigid versus flexible. And then the unstable trench bottom, rigid pipes will move when the trench bottom is unstable, whereas a flexible pipe wouldn't.
Okay.
It'll have a little bit of move, right?
Right.
Given the unstable bottom. So again, just looking at this quick list down here, rigid pipes have the following characteristics. It's made in discrete lengths. It uses gaskets and joints to form a watertight seal, often produced with composite materials. Minor trench deflections are accommodated by joint deflections. That's because of an unstable base. And the design assumptions include sufficiently stable trench bottom to keep the pipe aligned. Bedding and primary backfill are really required to minimize the stress concentrations. So I think the reason why people would use a rigid pipe was mostly for its stability and durability, but it's only good as the trench, the stability of the bottom of the trench.
Sure.
Or whatever the bed it's laying in. Yeah, there's huge gaps in there if there's a flooding problem or moisture gets in and then the soil drops down, right? You could end up with gaps underneath that rigid pipe, and that's where you could get deflection. And then the joints would crack or the seals would break open.
Sure.
The difference with the other thing I've seen here with a flexible pipe is that it's made from a single homogeneous material, whereas the rigid pipe can be made of composite materials.
Okay.
And let's see. I didn't know that they said the flexible pipe, particularly if it's a metal pipe, if it's going to be flexible, it usually comes in rolls.
Okay.
So in other words, it's already being curved to that extent, whereas a rigid pipe is just lineal feet.
Right. Okay.
Okay. 14. Oh, can't answer that one either. Wow. I don't know how I missed those. Or maybe I'd put them somewhere else. Okay, I guess I got some homework to do for you on those. Interesting. Okay, sorry about that.
That's all right.
Oh, so when do you want to get together again? When's your exam? Are you?
My exam is tomorrow. Yes. So.
Oh, it is.
Yes.
So what are you going to do today and tonight?
Go probably run some more exam questions and just probably run through Building Instruction Illustrated and just kind of run over some things that I need to brush up on. So, and look at my cheat sheet for just kind of.
Okay. So this question on the fixtures in the building, what the calculating location, was this plumbing fixtures?
It was basically
based on the water pressure, right?
Yeah, it was saying. So this, and I can send you these questions too. It was saying that if you have a water tank located at the top of the building, let's say you need to place a shower near the top of the building, and the shower needs 12 psi. So the question was saying, how much lower from the water tank should the shower be located?
Okay. Yeah, send me that question if you can.
Okay, I will.
I can send you the quick solution.
Okay, and the other calculation one too is it was saying water pressure at a water main connecting to a building is let's see, 50 pounds feet over square inches, and it's saying at 100-foot elevation above this point, what's the pressure? So I guess it's saying, calculate the water pressure if you have a high-rise building, at near the top of the building compared to what's being pumped into the building. So
yeah, send me those two questions, and I'll get an answer before. When's your exam?
Tomorrow morning. So
yeah, that's a good time to have it. Actually, you want to have it in the morning.
Yeah, I'd rather have it in the morning than just
Okay, well, I'll see if I can get these to you before tonight.
Okay, excellent. Okay.
Okay. All right.
Sounds good. Thanks, Paul.
Yeah, bye.
All right, bye.